Right, now that we've covered topics from basic integration all the way up to real-time mixing, it's time now for one last big challenge. As always, I'm going to set you a challenge and demonstrate some audio that I've implemented into my project. Your job is to then implement the same audio yourself without my help. This time, however, there will be a slight difference. Underneath this video, you'll find two additional videos. The first is a hint as to how to complete this challenge, and the third is where I'll show you how to complete the challenge in full. So if you find that you're struggling and would like a bit of guidance but don't want to be told entirely how to complete the challenge, then feel free to check out the hint video for some help. Once you've done that, you can give the challenge another try and then compare your method to mine using the final video below. Make sense? Cool. Then let's move on to the challenge. Now we've covered a lot so far in this course, and whilst this challenge won't test your skills on every topic we've looked at, it will test many. So for today's challenge, I would like you to implement the engine idle and the engine driving audio clips into our game using the tank movement script. Engine idle should play whenever a tank is not moving, and engine driving should play whenever a tank is moving. Also, each tank should be playing its own instance of these sounds, so if one is moving and the other isn't, the moving tank should be playing engine driving, whilst the still tank continues to play engine idle. You're also allowed to add a new audio source to the tank prefab for this, however you may only add one more. Both audio files must share this audio source, and your script should switch between the two when a tank starts moving or has stopped. Okay, so let's take a look at the bonus challenges. First, randomly modulate the pitch of both clips as they are played. Prevent the audio echo filter attached to our tank's prefab from processing the two new audio clips without removing or disabling it, and send these clips to their own audio group in our mixer so that they don't duck our music's volume. Okay, so this is how your game should sound. Now before we start this challenge, I'm going to quickly show you a little bit about detecting player input. Now we've touched on the get button down function before when detecting a single button being pressed. However, in order to play the engine driving clip whenever a tank moves forward, we'll need to know how to check for more than just a single button press. Remember, there are two tanks being driven by two players in our game, and each player has a total of 4 different buttons to control their tank's movement with. Player 1 moves their tank with W, A, S, and D, whilst player 2 uses the up, down, left, and right arrow keys. Now remember back to our input manager, which we looked at in lesson 3 of this module. We can use this to see which axis we'll need to use when checking for those buttons. The 4 axes we're interested in are horizontal and vertical 1, which hold the buttons that player 1 can use to steer their tank, and horizontal and vertical 2, which will hold buttons for player 2's tank. If we take a look at horizontal 1, we can see that the buttons mapped to this axis are both A and D, with A being labelled as the negative button and D as the positive button. The reason it can hold 2 buttons is because the axes within Unity's input manager work on a scale from -1 to 1. When the positive button on the axis is pressed, the axis outputs a value of 1, but if the negative button is pressed, it outputs a value of -1, and if neither are pressed, it outputs 0. So in our script, we can check the value of our axis, and if it is anything other than 0, then it must be either -1 or 1, which means one of these 2 buttons are being pressed. To show you how to do this, I'm going to quickly demonstrate a new function that we can use from within the input class. Inside of the update function, I'm going to create an if statement. In that statement, I'm going to check to see if either the A or D keys are being pressed. So inside of the condition brackets, I'll use the input class, and then from it, I'll call a function called getAxis, which gives us a number between -1 and 1, depending on which, if any, of the buttons on that axis have been pressed. First, I'll need to tell my script which axis I'm interested in by writing the name of one of our axes as a string. So let's write horizontal 1. Now I can say that if the number outputted by the axis is not 0, then either the A or D button must be being pressed. From there, I could do anything, play a sound, move a tank, etc. Now let's say that I wanted to check to see if A was being pressed specifically. Well, instead of checking if the axis is any number other than 0, I need to check to see if it is a number less than 0. As remember, A was the negative number and is therefore represented by -1. So I would instead write less than -0.1. Now, whenever a button on an axis is pressed, the axis doesn't give us a whole number straight away. It actually rises up through all of the possible decimal numbers in between. This is so that we can check for input from an analog stick on a controller. Analog sticks aren't as binary as a single button because they don't have to be pushed all the way in a given direction. Alternatively, we could use the getAxisRaw function instead. This will only output the whole numbers of -1, 0, and 0. So if a key is pressed, the axis will jump from 0 straight to 1 or -1. So using this function, if we wanted to check to see if the A button is pressed, we'd simply compare it to -1. Alternatively, you could get the name and the value of those axes and store them in variables. So we could declare a float variable called axis value, for example. Then in the update function, we could set the axis value variable to the value that is being outputted by our axis. To do this, we would write the variable's name and then set it by writing input.getAxis brackets horizontal 1. Then inside of your if statement, you only have to check the value of your axis value variable. Now I personally want this challenge to be, well, challenging, so the rest is now all down to you. As always, you may use previous lessons from this course, as well as other online materials you can find to help. And of course, don't forget to check out the hint video if you need some extra help. Give it your best attempt, and once you're finished, scroll down to the third video where I'll explain how I went about completing it myself. Good luck!